Morning class, or my bad, it's afternoon now. We're here this wonderful Monday. Yay, second week of the 6 weeks, 4 more to go. I really do miss you guys, and I would have to say it sucks that we're not going back to school. But anyways, let's move on, let's move forward. We'll finish it up, and whenever we do see each other, we will see each other and be happy and be better for it. So here we go. We're doing our new lessons. We're going back a couple of chapters. We're going to 9.1. This will be homework 1. And it's a short homework assignment. It's only 6 problems, 6 graphs. So we're dealing today, we're going to go over 2. We're going to do 9.1, 9.2. This first one, 9.1, deals with reflection. Well, you already know what a reflection is. It's a mirror image of yourself. Typically it's like a backward image. You take a picture off of a mirror, your left side is your right side and your right side is your left side. But here we go, we're going to deal with a coordinate system. You're going to get what's called a pre-image, which is the original image. And then you're going to create what's called the reflection of it. Okay? That's a form of transformations. We're going to deal, this whole chapter has transformations in it. We're going to deal with reflection, rotation, dilation, you name it. Okay? Alright, so for reflection, there's several ways to reflect. We're going to reflect, one would be across the x-axis. That means that the horizontal axis, you're going to reflect up and down. So if that's the case, if we reflect across the x-axis, I want you to pay attention to this. If we reflect, and this is for all of them, reflect across x-axis, that just means, one, x-coordinate remains the same. Here's what happens to the y-coordinate. Number 2, y-coordinates become their opposite. If we look at number 1, notice this one is reflecting across the x-axis. Notice how all the x's remain the same. The ones that change and simply become their opposite, well, for 2 becomes -2. Bam. 7 becomes -7, and finally 1 becomes -1. Exactly the opposite. And that's it. That's all that happens with the reflection. So you plot the originals, what gives you the original, or the pre-image, or the image, and then you change and you plot the second one. Notice how the notation is always with a small little quotation. Well, that's the changed image. So now we're going to deal with reflecting across the y-axis. So if we are going to now reflect across the y-axis, well, that is the vertical line. Notice what's going to happen for this one. This one's also an easy one. The y's stay the same, kind of like on the x-axis. The x stay the same. The y-axis, the one first is the y-coordinates stay the same. guess who changes? X coordinate becomes its opposite. Notice number 2. Number 2 says reflect across the y-axis. So all of the y's remain the same. But what is going to change is all the x's. So that 1 becomes a -1, opposite. For Q becomes the 2 becomes a -2. For R, the +8 becomes a -8. For S, the X is a 7, so it becomes a -7. And now you have the reflection coordinates. So you plot the pre-image right here. That's all the originals. And then all the ones with a superscript, the notation R prime Q1 S1 P1. Those are the new coordinates, and you will do that for all your work. You'll write the regular letter for the actual image that I give you, and then when you set up the new coordinates, you're going to plot the new ones, and you're going to use the notation. So if it's P, it'll be P to the power of 1, Q to the power of 1, and so forth. Moving on to now, if I give you any sort of line, either y equals x type or y equals -x. That all depends which one it is. Each one of them comes with their own specific rules, and all you do is to follow them. You actually don't need to graph them if you understand the steps. So when we go into this section right here, diagonal lines in the form of y equals x or y equals -x. We'll look at problems number 9, 10, 11, and 12 on the examples. Let's go ahead and do that so you can see what I'm talking about. So for number 9, this one requires you to reflect y equals x. Okay? So for y equals x, for this scenario, if you notice, there's only one step. Flip coordinates. That means your x becomes your y, and your y becomes your x. They just flip. So for number 9 and number 10, notice how for x we have -5 comma -2. -5 is your x value, -2 is your y value. All they did was switch. They flipped. And let's look at number 10. Let's look at h. +7 was your x value. It became your y, and -1 became your x. So as long as you remember these rules, I would probably write them down on a separate paper, a lot neater than what I have written down, but that way you understand what's happening. So then all you do is you have your original image. You can plot the original image. There it is. And then you can flip all your coordinates, write them down, and then plot those. Now we're looking at y equals negative x. Okay? So when we are reflecting, when we reflect on the line y equals negative x, here's what you're going to do. Step 1, change coordinates to their opposites. And then the last step is flip them. Notice on number 11, A, first thing we do with A is we do the opposites, or opposites of the coordinate of A. So negative 1 becomes positive 1, positive 3 becomes a negative 3, and then we flip. Bam, bam. Then we do B. Well, 0 doesn't have a positive or negative, so 0 stays 0, but 6 is positive, so he becomes negative. Then you flip negative 6, comma 0. And if you look at C, well, C starts off with 3 comma 5, so we change to their opposites, so it's negative 3 comma negative 5, and then we flip. Same thing happens with number 12. I'm hoping I gave you enough steps to do this first transformation, which is all just reflections. So I would write the coordinates first and then do the changes, and if there's more than one step, I would do them all if I were you. And then on these, I'm not giving you the answers because that's pretty much it, and then you just have to draw the figure. So you will have to do some of the work here. If you do have any questions on any of them, I will happily give you some examples. Okay. Let's see. You will have to do all 6 of these. I think that's only, you have a 1-pager assignment. It's only 6 graphs you have to do, and changing coordinates. I don't think that's hard. There's not a lot of math besides what you have to do here. So let's. Actually, I lied. There's still one more part. You do have examples such as 5 through 8. Let me gather my notes and I will give that to you right now. Like I said, you do have assignment 1 through 6. Give me a couple of seconds and then I'm going to give you notes on 5. 5, 6, 7, and 8. Okay? Alright, for number 5, when you're asked to actually reflect across a specific line, like x equals 4, or x equals negative 1, or y equals 2, or y equals negative 5, each one of these is going to affect the letter it's talking about. So for the x equals 4, x equals negative 1, on 5 and 6, they're going to affect the x's. Okay? Now I'm going to give you the steps on how to do that. Okay? If it's talking about y equals 2 is reflecting against y equals negative 5, well, it's going to affect your y's. Okay? So, when it's reflecting on x equals, and I'm going to put x equals a number, question mark. We won't know what it is until it's given to you. So, first step, well, first of all, your y values remain the same. Second step, the value given by x equals will have the x coordinate subtracted from it. Giving a total. Third step, this one is probably the most work you'll have to do. You add your value given by x equals to your total. So take for instance number 5, x equals 4. This is my x value given. All my y's will remain the same. The only thing that's going to change are all my x values. So for j, after I know that all the y values stay the same, step number 2 says the value given will have the x coordinate taken away. So the value given to me is 4. I'm going to take away 1, which gives you 3. Your new coordinate, which is in step 3, is simply to take your value given and add in your total, and that's 7. Now you do the next letter. Now we're doing K. Value given
I don't know that.
minus 2, which is 2. The third step says you take the value given and you add the total, and that's your new coordinate. Last one, we have 3, so you take your value given, you take away the 3, and it gives you 1. Then you take the value given and you add the total, and that's your new coordinate. That's how you get those. You're going to do the exact same thing for y equals. The x's will remain the same, but the y's will change. So, step 1, the x values remain the same. This one is on the reflection of y equals a number. If that's the case, this changes to your y value number given. So the value given by y equals will have the y coordinate subtracted from it, giving you a total. You're going to add your value given by y equals to your new total. So if we look at number 7, let's take for instance C. Here's that. Here's my value given. You're going to do 2 minus negative 4. Well, 2 minus negative 4 becomes 6. Then you take your value given and you add the new total. That equals 8. Bam. You go to the next one, D, 0. So it's 2 minus 0 equals 2. You take your given value, you add the total, and you get 4. There you go. E, 2 minus 1 equals 1. Take your value given, you add your new total, and you get 3. Lastly, we have the negative 3, so it's 2 minus negative 3, which ends up being 5, and then 2 plus 5 equals 7. If you have any questions on any of these, again, let me know. Put it in my private comments, and I'll be glad to help you. These will probably be the more difficult ones. Be more than glad to help you with any of those. And let's see, this I'm giving to you today, so I'll pick it up on Friday. Alright, I'll start grading. I am already grading some of your other assignments, so I'll start posting those grades on Skyward so you know where you're at. Alright, hope you're doing well. My family and I are keeping in, staying safe. It's a little claustrophobic, but we're good. Hope you have a good day.